Hello. Okay. So, hello everyone. Today we will be solving some questions from our senior sheet. So, we will be solving this question F DQ. So, let's start by understanding what is the question. So, okay. So, before starting, we will discuss like what we will learn from this today session. So, like DQ is a data structure. It is a modified data structure which you can think of like it's a doubly ended queue. So I hope you have idea of queue. So let me first just give you a brief introduction of what is a queue. So just let me give you a brief glimpse. So as we know that stack is such a data structure such that like we can push elements into it and pop elements from the top of it. So it is called an FIFO data structure, right? Sorry, not FIFO, LIFO, last in first out. It's an acronym for this, last in first out. So the element which is last pushed into it, it is the element which is first popped out. So this is a stack data structure. What is a queue data structure? Like a queue data structure says that if you push elements into it, you can just pop out from the front of the elements. Okay. So this is a FIFO data structure, first in, first out. Okay. Just a minute. First in, first out data structure. Okay. FIFO data structure. However, now what is a DQ? It's a queue which is doubly ended. So in queue, we know that we can push elements at just one end and pop out elements from the other end. But in DQ, what we can do, we have this functionality as well. And addition to these, we have functionality such that we can add elements from the back of the it and also pop it out from here. So basically, you can do all these four operations in the DQ and also an order of one time. So all these operations are of order of one time. So in this you would have been given a DQ, like it's an initially empty, so you can think like nothing is present here. And there are queue queries and you have to just perform all these operations. So if pushback is there, you need to push the element. If push front is there, you need to push element from the front, right? If pop front is there, you need to pop element from the front. And similarly, if pop back is there, you need to pop element from the back. If front is there, you need to print the front element. And back is there, you need to print the back element. And print X means you print the element in the index of the DQ. Okay. So in the DQ, you have to print at like if print X is there, so at which index, so at that particular index, which element is there. Okay. So we can just simulate the process, and I hope that would be good enough to solve this question. So let's code it side by side so that you will can get the idea. So first, like there are 16 queries. So first we'll take what amount of queries are there, right? And for each queries, I have to what? Uh, Input a string first and then a number, right? And depending on which type of string, I need to input a number. So first I input the string. Now if string that is equals to pushback, right? Or else if s string that is equals to I guess pop back, push front. Okay, push front. Okay, else if sorry, else if uh, string is equal to print. Okay, so in these all cases I again need to take an input again, like denoting which all elements is together. So let me denote it as an x. So let me just copy paste it here. Yep. So in other cases I just need to perform other operations. So if that is equals to uh, pop front, pop back, front and back, right? Pop back, pop front, and else if uh, front and back, right? Now this automatically equals to back, but still we can just add it for safety reasons. Like it will help us know what we are evaluating. So that's so just let me check. Push back, push front end, and print. We have to input a vector x, value x. Push back, push front and print. Okay, and then all of the cases pop back, pop front, front and back. Yep, front and back. We need to input this thing. Now based on this we have to add do operation. So in this pushback we can just okay, so let me first let's initialize a deque. So you can initialize just as a queue by writing the syntax. Okay, let's name it as deque. I think I made some spelling error. Deque. Okay. Now if pushback is there, I can just deque dot pushback x. Okay. If push front is there, right, I can do deque dot push front. These are all inbuilt C++ functionalities which are provided. Okay. And if print is the okay, let's evaluate this case afterwards. If pop back is there, I can just do pop back, right? If pop front is there, I can just do pop front, right? If front is there, I can just print the first element, right? Because in this we have to print that. So deque dot front, right? And in this we can just print deque dot back. Yes. And let me also give an ending extra line here. So yeah. Yes. So just this case remains that how can we evaluate the print functionality. So what do we need to do in print? We need to print the element in the index of the deque. Okay. But while printing we also need to take care of those all those things that like if we are pushing back or popping back an element, or maybe we are adding back an element or adding to the front of an element, then the index value of that changes, correct? But we need to handle that smartly, otherwise we can run into TLE easily. We can run into TLE. So what can we do? Let's evaluate it. So let's take this example. So if deque is initially empty, I pushed back 5, right? I pushed back 5 value, correct? In the first. Then I printed the value of front, which is 5 itself, right? Then I printed the back element, which is 5 itself. Then I push back 6, right? Then I print the first element, which is 5, sorry, which is 6, yes. Then I printed, okay, sorry, 1, 2, 3, 4, yeah. Yeah, so front element was 5. Okay, so this is the front side, this is the back side. So front element was 5 and last element, back element was 6. Now I push front 3, so 3 will be pushed there, right? Now I printed the first element front, which is 3, indeed, correct. Then I printed the back element, which is 6, that is indeed correct. Then I printed 2. Now I need to print the index value, like the element which is present at the index 2, right? So if I do a print of 2, I need to print which element is present at which position, correct? Now, I think, yep, yep. So just only just Q queries are there, and yep. So now again pop back is there, so we can pop the last element out, correct? So 6 is popped out. If front is there, we can just print a 3. Sorry, front, एक second. Front and back, right? Okay, so 5 and 3 were printed. Similarly, pop front and back. So these all can be evaluated now. Now a question remains that how to figure out like how can we print the value which is present at that index. So you can just think for a minute, and then I will come back to you. Okay, so I hope you try to figure it out what could be the solution. So let me tell you, there exists a functionality in the deque which says that if you directly do that deque dot at, and if you input the position, then you get the answer. So if you in this, if I just write dq, select cout dq dot at x, then I will get answer. But also we need to take care of the one base syntax, so let me convert it into zero waste. So now let's run the code here. So yes, I think, yeah, it's passing. Let's try to submit this now. It was question number, okay, DQ. Yep, I think it will pass now. Okay, it's passing. I guess the compiler is slower right time this time. Yeah, it passes. So yes, I hope you got the solution. Thank you.